Identify the conic given by the equation 3x squared minus 4y squared plus 6x plus 16y minus 25 equals 0. And after we identify, we're to find the standard equation, find the foci and vertices, and if it's a hyperbola, we need to find the asymptotes. And finally, at the end, sketch the graph. And so we must start by completing the square. We have 3x squared plus 6x plus something that we're going to add to make it a perfect square. And we have minus 4y squared plus 16y plus something that we're going to add to make it a perfect square. And we're going to move the 25 over to the other side, and whatever we add to the left we'll also add to the right. In order to complete the square, we have to factor out the coefficient on the squared term. And so that's going to leave us with x squared plus 2x plus something. Take out a negative 4, leaving us with y squared minus 4y plus something. And that's equal to 25 plus the things that we're going to add to the other side. We like for each of these guys here to be perfect squares. And so what's going to happen then, we take the variable, we take the sign in front of the x term, we take half of the coefficient on the x term, and then we square that. That's the relationship between the perfect square binomial and its multiplied out version. But it's not a 1 that we're adding because of the 3 that we factored out. It's actually a 3 that we're adding because of distribution, distributing the 3 across. We have a minus 4 on the outside, and then we factor again, perfect square again, where we take half of the 4, we get a 2, we square that 2, and we get a 4, but what we're actually adding is in fact a negative 16 because of distribution, distributing the negative 4 across. And so we have the 3 on the right hand side as well, and the negative 16 on the right hand side as well. And altogether, what's on the right hand side, 28 take away 16 is 12. And the final step to get into standard form and recognize the equation is to divide by 12. Because we have it set equal to 1 on the right hand side. And so our equation is x plus 1 quantity squared over 4 minus y minus 2 quantity squared over 3 is equal to 1. That answers the first question in standard form. And with that minus there, we recognize it as a hyperbola. We have to find the foci and the vertices. We have to also find the asymptotes. Okay. And so what we have with the hyperbola is that a squared is 4 and b squared is 3. And in order to get the foci, what we need is the variable c. And the relationship between a, b, and c in a hyperbola is that c squared is a squared plus b squared. It's a different relationship for the ellipse. And so c squared is equal to 16 plus 9, conveniently c squared is 25. No, I'm sorry. Back that up. Sorry about that. A is not 4, B is not 4. It's that a squared is 4, and b squared is 3. And so we get that c squared is 7. So c is plus or minus root 7. Great. What do we do with this? Well, there's a center to this hyperbola. This hyperbola is centered at -1, 2. And what we do from the center is we add and subtract c along the major axis to get the foci. So the foci basically occur at c plus h, k, and c minus h. Sorry. Let's call it, sorry about that. Let's call it h plus c and h minus c. In this case, because x is the variable that's in front of the minus sign, so this opens up in the x direction, and so we add and subtract along the x. And so we get the foci to be -1 plus root 7 to -1 minus root 7 2. Same thing with the vertices. What we do with those is we add and subtract a from the center. So for vertices, we take h plus a, k, and h minus a, k. And so a is equal to 2. A is equal to 2. And so we have -1 plus 2 and -1 minus 2. Great. So we have our foci, we have our vertices. The last thing we need that they ask for is the asymptotes. And for the asymptotes, we have the equation that y minus k is equal to plus or minus b over a times x minus h. And so that's going to be for us y minus 2 is equal to plus or minus b squared is 3, so b is root 3 over 2, which is a, times the quantity x plus 1. And so we have the equation of the two asymptotes. We have the two vertices. We have the two foci. And we have the standard equation. And we're running out of time. We can sketch this on the next video.